These are practice exercises from page 145 of the textbook. Now we're looking at performing stoichiometric calculations with reactions that are taking place in aqueous solution. So we're dealing with neutralization and precipitation reactions. So anytime we do a problem, we want to think about what our game plan is. We know that we are solving for grams of sodium hydroxide in this first one, and they're giving us a volume and a molarity of an acid, sulfuric acid. So we know that we need to write a reaction for this. So let's go ahead and think about what reaction is going to happen when these two substances react. In order to understand what the reaction looks like, we need to figure out what ions these things are composed of. So sodium hydroxide is made up of the sodium cation and the hydroxide anion. Sulfuric acid is made up of two hydrogen ions and the sulfate anion. So when this reacts, we are going to have NaOH reacting with sulfuric acid. We know that our cations and anions are going to switch partners, so the sodium is now going to be with the sulfate, and I know that I need two sodium atoms to balance the charge on the sulfate, so Na2SO4, and then H plus and OH minus make water. This makes sense. In neutralization reactions, we should get water as a product. Next thing we want to do is go through and balance this. Since we see that we have two sodium atoms on the product side, we want to make sure we also have two on the reactant side. Two hydroxide ions, two hydrogen ions means that we need to have two water molecules forming as well. So that's our balanced reaction. Now let's think about what our game plan is. We've got a molarity and a volume of sulfuric acid. So we know that we can calculate moles of sulfuric acid. We're going to use the balanced reaction to figure out moles of sodium hydroxide, and then we know how to change moles into grams. So in order to do that, we need the coefficients here. And here we need the molecular weight of sodium hydroxide. So the molecular weight of NaOH to 1 decimal place is 40.0 grams per mole. So now we have everything we need to start this calculation. In order to get moles of sulfuric acid, we need to remember that molarity, capital M, is equal to moles over liter, so we can use that as a conversion factor. They're telling us that we start with 20 milliliters, so that's 0.020 liters. We know that there are 0.150 moles of sulfuric acid for every 1 liter. Again, that's just the molarity rewritten as moles per liter. We know that we really don't want moles of sulfuric acid. We want moles of the sodium hydroxide, and that conversion factor comes from the coefficients. So looking at the balanced reaction, we consume 2 moles of sodium hydroxide for every mole of sulfuric acid. And then the last step is getting rid of moles of sodium hydroxide because we actually want grams. And we know that there are 40.0 grams in every mole. So watching our units here, we're getting rid of the liters, getting rid of the moles of sulfuric acid, getting rid of the moles of sodium hydroxide, leaving us with grams of sodium hydroxide. Looking at our significant figures, the two numbers we started with have 3 significant figures, so our final answer will also have 3 significant figures, so that's going to be 0.240 grams of sodium hydroxide for our final answer. So these are very similar to the stoichiometry problems we've done before. In fact, this entire half of the calculation we've done before. This was from a previous chapter. The only thing that was new is now we can use molarity as another way to get to moles. So instead of just converting grams to moles or atoms to moles or molecules to moles, now we can use concentrations to get to moles. So we're going to do something very similar in the next problem. Now we don't have a neutralization reaction, now we have a precipitation reaction. We're going to want to do the same thing. We're going to want to write out our balanced reaction. So in order to do that, we need to think about what ions are present. So HCl, H plus, Cl minus, lead 2 nitrate, Pb2 positive, NO3 negative. And they're telling us exactly what our product is, which was very nice of them, so we don't have to use the solubility rules to look this up. So again, let's go ahead and write out our balanced chemical equation here. We've got the sulfuric acid, which they've told us is aqueous, reacting with the lead nitrate, which they've also told us is aqueous. We know that it is producing a precipitate. So then what else is left to form? We know the precipitate happened because the lead combined with the chlorine, so the only other thing that could form is the hydrogen reacting with the nitrate, so that must be HNO3, because the charges cancel, and that is going to be soluble. We know anything that contains nitrate is soluble, and this is one of our strong acids. Okay, next thing we want to do is balance this. Since there are 2 nitrate molecules on the reactant side, we want to make sure there are 2 on the product side. Since I see 2 hydrogens and 2 chlorines on the product side, I want to make sure there are 2 on the reactant side. So now we've got this balanced. So let's think about what our game plan is. We know that we are starting with that 0.1 mole of the lead nitrate, and they're asking us how many liters. So if I have moles of PbNO3 but I really care about HCl, I know I can use the balanced reaction to figure out how many moles of HCl I have, and then I need to get to a volume of HCl. So in order to do the mole to mole, I'm going to use coefficients in the balanced reaction. In order to get from moles to volume, I can use my molarity. So starting off this calculation, I've got my 0.100 moles of lead nitrate. I know that I really don't want to talk about moles of lead nitrate anymore. I want to think about moles of the hydrochloric acid. Based on this chemical reaction, I know that I consume 2 moles of acid every time I react with 1 mole of the lead nitrate. But again, I don't really want moles of the hydrochloric acid, I want a volume. So if I want a volume, I need to know the relationship between moles and liters. And the relationship between moles and liters is this molarity, this 0.5 molar. So I know that there are 0.500 moles per every 1 liter of HCl. So looking at my units here, the moles of the lead nitrate are going to cancel, the moles of hydrochloric acid are going to cancel, and I'm going to be left with a volume in liters. So doing the math there, you're going to end up with 0.400 liters of the HCl solution. So that's how many liters you need in order to perform this reaction. Again, there are a few different ways to solve this problem, different ways to use molarity instead of using it as a conversion factor, so do whatever makes the most sense to you. Just make sure you can explain why you're performing each of the steps.